Hello, algebra. This is our first video with lesson 7.1, which is multiplication properties of exponents. You have actually the benefit that I've been trying with the other grades, so this video will not be as rough as like 6th grade. Anyway, I hope you're socially distancing yourselves from each other, but still maintaining contact. And let's get started. There is one thing that I wanted to go over, and that is what a monomial is. A monomial, mono means one, and loosely in math it means one term. So it is one term. There is an exception, an expression that involves division by a variable, like AB divided by C. This is not a monomial. Even though it's one term, we are dividing by a variable. That's not allowed as a monomial. So how this is going to work is we're going to go over several together. Then you're going to try the rest on your own. You may use a calculator during the course of this. I don't know that you will need one for this, but let's go ahead and get started. So have 7.1 out, and we are going to do the odd ones together. The first section says, determine whether each expression is a monomial. Write yes or no, explain. 11, is 11 a monomial? Is it one term? Well, the answer is yes, it is one term. And actually, it is called a constant. All right, number 2, you're going to do on your own. Number 3, is this a monomial? It is one term, but if you will notice, we have a variable inside like a division problem. So this is a no, it's that exception. No, because it involves dividing by a variable. Okay, let's look at 5. J to the third k. Is this one term? Yes, it is. One term. Very good. All right, do the others on your own. Now, multiplication properties of exponents. This was unit 1 in pre-algebra. So this should not be new to you. So when you are multiplying two terms and they have the same base but different exponents, do you remember what you do with the exponents? Well, you add them. Okay, so let's look at 7. A squared times a to the third times a to the sixth. This is just a multiplication problem. We've got the same bases, so we add the exponents. 2 plus 3 is 5. 5 plus 6 is 11. So this is equal to a to the 11th power. Let's look at 9. 9 is a little bit trickier. It's not that bad, though. We've got y squared z times yz squared. So what you're going to do here is multiply you have to multiply the ones with the same bases. So if we look at this, we've got y squared times y. Well, this y is to the first power. So y squared times y to the first power, you would add the exponents. So it'd be y to the third power. And then we've got z by itself. Again, z by itself is to the first power times z squared. And so z to the first power times z squared is also z to the third power. So that equals y cubed, z cubed. All right, let's look at 11. A squared, b to the fourth times a squared, b to the fourth. All right, so you're going to multiply your a's together. A squared times a squared is a to the fourth power. B to the fourth times b to the fourth is b to the eighth power. I hope you're catching on. 13. Now this is interesting because we've got a coefficient, a base with an exponent, coefficient, base with an exponent. If it's a multiplying problem like this, you can multiply the bases and then multiply the exponents with x as the base. So 2 times 3 is 6. X squared times x to the 5th is x to the 7th. All right, 15. We're getting a little bit longer term, but we work it the same way. 4xy cubed times 3x cubed y to the 5th. So we multiply our coefficients. 4 times 3 is 12. X times x to the 3rd, that's x to the 1st times x to the 3rd is x to the 4th. Y to the 3rd times y to the 5th, y to the 8th. All right, let's look at 17. Negative 5m cubed times 3m to the 8th. So you would multiply your coefficient. Negative 5 times 3 is negative 15. M to the 3rd times m to the 8th is m to the 11th. Okay. All right, 19 is different because this was multiplying the same base, different exponents you add. This is a power raised to a power, raised to a power. So 10 squared to the 3rd power is like 10 squared times 10 squared times 10 squared. I hope that makes sense. 10 squared times 10 squared times 10 squared. That is 10 squared raised to the 3rd power. Well, this is 10 squared times 10 squared times 10 squared. We just were doing that would be 10 to the 2 4 6th power. So when you're raising a power to another power, you actually multiply the exponents. So 10 squared raised to the 3rd power is 10 to the 6th power. All right, negative 6p squared. All right, now this, I want you to realize that when you're raising this to the 2nd power, you have to raise both the p and the negative 6. So negative 6 squared is negative 6 times negative 6. Negative 6 times negative 6 is positive 36. P raised to the 2nd power would just be p squared. So that is 36p squared. That's very tricky. If you've got a coefficient with a variable base and inside the parentheses raised to a power, you've got to apply that power to both parts. Okay, so the same thing here. 3pr squared raised to the 2nd power. So we got to raise the 3 to the 2nd power. 3 to the 2nd power is 9. P to the 1st power raised to the 2nd power. P raised to the 2nd power is p squared. And then r squared raised to the 2nd power, you multiply the exponents, would be r to the 4th. So 3pr squared raised to the 2nd power is 9p squared r to the 4th. All right, the last one we're gonna, well, I guess we're gonna do 2 of them. 25, this is geometry, express the area of each figure as a monomial. Okay, this is a rectangle. How do we find the area of a rectangle? Well, we multiply length times width. The length is x to the 5th, the width is x squared. So the area is going to be x to the 5th times x squared. Well, x to the 5th times x squared, we just were working on that. If you're multiplying the same base, then you would add the exponents, would be x to the 7th. So the area is x to the 7th. All right, then you're going to do the same thing with 26, finding the area, but this is a square. All right, the last one, 27. Find the area of the shape. this is a triangle. Now, how do we find area of a triangle? It is 1/2 the base times the height. So we are going to do 1/2 times the base. The base is 9p cubed, 9p cubed times 4p, okay? So I am looking at constants. My constants are 1/2 times 9 times 4. Well, 9 times 4 is 36. Half of 36 is 18. So my constant is going to be 18. P to the third times P would be P to the fourth. So the area is 18 P to the fourth. I hope that made sense to you guys. Try the rest on your own, and I will talk to you soon. Have a great day. Bye.